I'm from Baltimore, you say you was, I never see you. What part you on? I got some family on the Alameda. I love my city, that's about me, and I bet they know.
Hi guys, my name is Nako Nakatsuka. I'm a 4th year chemistry PhD student at UCLA, and today I'll be helping you guys out by going over some general chemistry concepts. And good luck with the course. Another thing I wanted to touch upon was how to handle double and triple bonds when trying to designate priority groups. And so multiple bonds actually add phantom atoms. So that sounds kind of crazy, but let me show you what I mean by that. So let me draw this simple molecule right here. And in this case, when I go to assign priorities, how do I assign the priority of this carbon right here, where it has a double bond to the oxygen? Well, first off, let me assign the priorities to all the parts that I know of. So OH is going to be the first priority because oxygen has the highest atomic number. Hydrogen is going to be the lowest priority because it has the lowest atomic number. So now I'm competing this carbon against this carbon. Well, here's where the multiple bonds become phantom atoms. We can now look at this top carbon as having 2 bonds to oxygen. So this oxygen is basically a phantom atom where it doesn't actually exist, but the double bond is making it appear so. And thus, when I draw this again, now it's pretty easy for you to see how I'm going to assign the priority groups. So this is 1, this is 4, and in this case, this carbon is bonded to a carbon, oxygen, oxygen, and hydrogen, and this carbon is bonded to a carbon, hydrogen, hydrogen, and then an OH. So in terms of the priority groups, this is going to be higher in priority because it has 2 oxygens versus just the 1 for this carbon. And thus this is going to be second priority and this is going to be third priority. So in the case that there was a triple bond somewhere, just remember you're going to add 3 phantom atoms and instead consider each of the bonds as an extra atom. So now I can draw this again in a more straightforward form now that I know what the priorities are, and I can show you guys what the designation is going to be. So I put the hydrogen in the back in the plane away from the board. This is priority 2, this is 1, and this is 3. So it's going to go from 1 to 2, 2 to 3, and thus it's R because it's going to the right. And this is glyceraldehyde. So as you can see, this is a really good thing to remember when you're assigning priority groups and you see multiple bonds. One thing I wanted to mention for you guys to be careful is the R and S configuration is the absolute configuration, right? And this is not equal to the plus and minus sign, which represents the optical rotation. And to be frank, there's actually no easy, predictable relationship between the two. And so just because something is R doesn't mean it's plus, just because something is S doesn't mean it's minus. The only thing that we can say about this is that an enantiomer of something that is S and minus is going to be R and plus because it has to be in the opposite direction in terms of the optical rotation as well as the designation. So just keep in mind that these are not directly related unless you're making the designations based on the enantiomers.